Hi everyone, welcome to this brand new lesson. In today's lecture, we are going to start gender classification using a male and a female faces. We will be actually turning on our cameras and then we will be clicking the pictures, and based on these pictures, we will be classifying the person either as the male or a female. So I'll be showing you the full code, the line by line, how you can code this lecture, and then how you can use the Inception version 3 deep learning model, how you can train your model, then how you can capture this photo in real time through your webcam in a Google Colab there. All right. So just to show you a demo here, that's what we will be doing here. We will be running here. All right. We will be coding it. So dynamically we are turning on our cameras there. So now you can clearly see my face is here. The video is being recorded, and I have zoomed this camera a little because we were testing the face detection. So I had to crop the image only till these faces. So that's how it is running there. Now you need to click on here the capture one. So once you click on the capture, okay, so you will get here the beautiful picture there. So once you get that picture is stored here, all right, in the photo there. And then there is the code. So once you run this, you will be getting here almost 79% of the accuracy that it is saying that it is the male face there. All right. So all those things you will be learning in this lecture. So stay tuned. Let's go ahead and get started with the gender classification using male and female faces. We will be using a deep learning model, which is Inception version 3. Alright, now let's go ahead and get started with the gender classification using male and female faces. We will be using here a deep learning model which is known as Inception version 3 model. Right, so we'll be coding in the Python, and we are using here a Google Colab, and in the Google Colab we will be using a GPU at the Google Colab. You can select GPU version of Google Colab by going in runtime and change runtime to here GPU version, right? And just click on the save. It will again disconnect and reconnect to a new machine which will be running on the GPU. So the GPU is actually necessary to train our model in deep learning models. All right, perfect. Let's go ahead and run this. So once you run this, you will see there that one says that this is a cell number 1. All right, so there are few these are a few of the Python packages which we have already imported, because these Python packages are so common and I'm sure you guys know about this. But quickly let me recap this. The matplotlib we will be using to plot some graph in our tutorial. NumPy is here a statistical, you can say the numerical computational Python package here. This the Pandas is there. So the Pandas is kind of the data frame management there. So we manage the data with the Pandas. The random is the random number generator. And there you have the OS, which is of course the operating system there. So here these are the important. Let me just quickly tell you. The TensorFlow as the TF, as you know, the TensorFlow is the TensorFlow where we do our deep learning coding there. And inside the TensorFlow there is the Keras application. So this utility is there. So from that Keras, there is the application. In that application, we have so many type of the functions, right? That's mean the deep learning models, which are the pre-trained deep learning model. All right, something like that. If you open that, you will get all these pre-trained deep learning model. From there, I had selected Inception version 3, this module, right? Perfect. So thereafter from TensorFlow.keras models, this is the sequential model. So we'll be building here a sequential model after the Inception version 3. So moreover, we will be importing Inception version 3. Thereafter, we will be adding some additional layer in this Inception version 3 model. There you have these layers. So there we have the layers, dense layers, flatten layers, batch normalizations, and dropout for the regularization. And these two Python packages, which are this image data generator, load image and image to array. So these two will be used to load the image data. So image data is the data of male and female faces that we will be downloading from my GitHub repository. You can go to Lakshmi made it there, github.com Lakshmi made it. then come to the repositories, and inside that you will have here male female face data set, right? Just click on here, there you will get all these data set, right? So we will be loading these data from here, right? So there inside this the female, you have all these data, right? Perfect. This one is inside the female, right? All right, and thereafter this ResNet weight. So we are also going to download here the weight of the ResNet as well. So this ResNet weight we will be using to train our machine learning model. So all right, instead of selecting this ResNet version, ResNet 50 weights, we should be selecting Inception version 3 weight. So the moreover, I'm just gonna copy this link, and then I'm gonna paste it here. Okay, this link is not there, no issue. Let me just get this, the final link is here. All right. Yes, so the final link is here. You go here and you get this Inception version 3 updated ResNet 50. So we are gonna get this one. You right click here and then this copy the link from there, and thereafter we need to replace this whole link from here, right? So there we are gonna get here Inception version 3 weights. Perfect. Just go ahead and run it. It will get the link of this, and later on we will be downloading this one. All right. So I'm just putting here the name is the ResNet. Instead of ResNet, I think let me put it here, this Inception weights path, right? So the reason it was the ResNet, actually I had taken it from my previous video tutorial. That's why I forgot to change it to the Inception version 3, but don't worry, right? All right, let's go ahead and see what is this Inception version 3. So Inception version 3 is a convolutional neural network, and it is advanced version of ResNet 50 and Inception version 2. And it has a 7x7 convolutional layers there, 1 2 3 4 5 6 and the 7, right? And before this Inception version 3, all these the fine tuning and other things were happening at the last stage, the mostly there. But after introducing this Inception version 3 and so many optimizations are also happening here before the final layers. We will be using Inception version 3 function from the keras. So there we will be passing here these parameters in Inception version 3. This include top says that if you want to retrain the top, that's mean the top layers of the Inception version 3, and if we don't want to train the top layer, we should pass there the include top equal to the false. And by default, it is taking here the weights from the ImageNet. Otherwise, we can pass the path of this Inception version 3 there, that path, and input tensors and input shape, all those things, that mean the data we can pass there, right? Perfect. Now let's go ahead and get started with the coding. So the first of all, we will start with the data preparation, and in the data preparation, we definitely need first our data set in our Google Colab. From there, you need to select here this HTTPS, get this link from here, and then come to here, and there I'm gonna just put here git clone. Perfect. Just run this. So once we run this, you will see here a new directory is there, a male female face dataset directory has came there, right? Perfect. Now thereafter we need to put here some hyperparameter tunings, like let's say I'm gonna put here this epochs. By default we can train it for a 50 epochs, since this is online video tutorial. Later on we will be just training it on just a single epoch there, and the learning rate I'm gonna put here the 10 power minus 3, that's mean 1 into e power minus 3, that's mean 10 power minus 3. And the batch size here I'm gonna put here the batch size is equal to 128, that's mean 128 images will be taken together. All right, perfect. Thereafter I'm gonna say here this one is going to be just the empty ones for the data and for the labels, right? Perfect. And the image size, which I'm gonna take it like the image width and height, which I'm going to put as the size is equal to the 224. So this will be height and width both, right? Perfect. So this size 224, I'll be taking it for both. Perfect. Now thereafter we need to here thereafter we need to write here our image loader, right? So I'm gonna just write here image data generator. So it means that now we need to load this image in the form of numerical data, because any machine learning algorithm works on the numerical data. It doesn't work on the text data and neither on image data. So all these data should be converted into the numerical data. So that's what we are going to do here. Now we are going to convert these image data in a numerical data. So the numerical data means it is going to be converted into some kind of the numbers where if it is a colored image, that's mean if it is colored image, then it will be converted into a three-dimensional image where we will be having like image height and width and thereafter the depth. So the depth will be there, the red, blue and green, right? That's the RGB there. So red, green, blue, those components of the image. All right, perfect. So let's go ahead and take first the training data generation. So I say here the train data gen is equal to image data generator, and there I have here this horizontal flip. I'm going to make it true. So the moreover, this is also going to be like the augmented data generation as well, right? Thereafter I say here this the width shift range. All right, width shift range is equal to 0.4. Thereafter we have here this height shift range is equal to 0.4. all right, perfect. Thereafter I have here this zoom range is equal to 0.3. There I have here then the rotation range is equal to 20. all right, perfect. Thereafter I have here rescale equal to 1 divided by 255. You may ask that this integer divided by integer, that may produce here a wrong result. Let's go ahead and see that how this is producing this. Even though if we put here like in the float value, we will be getting always the same result, so no issue. all right, so what these things are doing here, this horizontal flip are flipping horizontally the image. There is a little width shift range is there, so it's kind of the image data will be augmented there. The height shift will be there a little, a zoom will be also there a little, and some rotation will be also there, and rescaling, that's mean actual pixels of the image are 0 to 255, but we want to make it between 0 to 1 for a machine learning for a machine learning model training, right? That's how this train the data generation is going to be there. And let's go ahead and take this, the test generation. So test gen is equal to image data generator, and in that now we don't want to make any of these pre-processing in the test data. So that's the test generation there, which we will be using for a validation. Rescale is equal to 1 divided by 255 only. all right, so we have got these two generation there. And image size we have already taken that, which is 224. all right, and the batch size we have already taken. So the target size, what will be the target size, that's mean the image target size, that will be equal to size comma size. all right, that's mean you can say it like this, something like this, right? 224 like this. All right, perfect. So thereafter I'm gonna go I'm gonna do like this: the train data gen dot flow from directory. All right, and now I'm gonna put my training data path here. So the training data path, which is actually saying that the directory here. So for this directory, I'm gonna put the training data path, which is here. Right click and get this copy path there. So inside this we have male and female folders, and inside this female we have all the female images. It's not loading because it's a quite huge data set, and if you see here on the GitHub, you will get that, right? So inside the training, if you go through the female, you will get all these images there. So that's how we go to the training images. So the labels, it will automatically find out there are two folders, female and the male. That's when there are two classes, male and female classes are there. Then there is the target size. The target size means is that what is going to be the size of the image. So I say that the target size is going to be the 224 cross 224. That's the target size there. And similarly, I say the batch size. Batch size was already selected as the 64. So that's what it is going to be here. Either it was 64 or 128, I think. Okay, it was 128. So there the batch size is there. And then thereafter it says that what is going to be the class mode. All right. So the class mode means what type of the classification is this? So this one is actually a binary classification. Why binary classification? Because there are two classes here, male classes and a female classes are there. So that's why this is a binary classification. Just run this. So we have got here our train data gen. All right. So in fact, I need to store it in a variable. Otherwise it will be useless. So there I say here the train generator. All right. So this one is going to be the train generator. And similarly, I'm going to do here our validation generator. All right. So the validation generator is equal to, we had there the test generator. That's mean the test generation. All right. Test data gen. Do you know here this one dot flow from directory. That's what I have got here. Sorry. Thereafter I need to pass all the information as I did here. So I'm just going to copy all these information and then I'm going to paste it here. And instead of that training, I need to pass now here the validation information. Right? That's how it's going to work here. There now we have got the validation data generator. So in the training, we have found 47,000 images belonging to two classes, and in a validation, we have got here 11,000 images belonging to two classes. All right, perfect. So all these information we have got here, and similarly, you can also know here the classes as well. So you can say like this: train generator dot class indices. Right. So from there you can get to know that, okay, these are the class indices, and many other information. In fact, you can get it from here. Like if you type here the train generator dot classes, you will get these classes for this train generator. So these classes are long enough to accommodate all these 47,000 and this much of the data set. I mean, if you get here the length is there, so you will get the same length because images are the input and these are the output which will be used for the classification as the target output. All right. And similarly, you can use here the train generator dot class mode. So this class mode says that the binary there. All right. So all these information you can get it from here itself. Perfect. All right. Superb. Now let's go ahead and see any data inside the train generator. So you know we have given here the batch size of 128. That's mean these training or validation data generator have a data in a batch of 128. That's mean 128 images are grouped together. To understand that, we can do like this: the train generator dot next. All right, let's say we do like this, x and y equal to like this. Now if you get this x, you will get that a quite huge array of x. And if you calculate this, the shape of x, where is this? Just a second, it is here. If you calculate the shape of x, you will get here this information, this 128. So this 128 is actually the batch size. So we used 128 images there in one batch, and one image data is like this. And if you remove that shape, so you will get there the only one image data, right? So this is the 3-dimensional image there. So, all right, so this one is for one dimension, here is for the another dimension, and like that. All right, perfect. So this is like you do see here, these are there are the RGB component there. All right, that's why these three are coming there, RGB, right? So for each image we have the RGB components as well there, right? Because these images are colored images. If we load it as the color image, we will pass it as the third dimension, which will be used as red, green and blue. All right, perfect. All right, now it is time to build our model. So I'm just gonna build our model here. All right, so build ML model. I'm gonna build this ML model like this. Model is equal to sequential. Thereafter model dot add, and inside that I have here this Inception version 3. If you remember earlier, I told you guys that we will be saying that include top equal to false, because we don't want to retrain this model. And thereafter there is the poolings. So pooling, I'm gonna use here the average poolings there. That's mean those while doing the pooling, so all the pixels weight will be averaged there. All right, thereafter I have here this weights. Now there are two options: either we pass this ImageNet weight, otherwise we can pass the Inception one, right? If you remember there we had Inception. What was the name of that? Let me see. I think here it was Inception weights path. All right, so this one is going to be the weight there, and thereafter I'm gonna say here this the model dot add. Now I'm gonna do here this the flattening of the layer. So I say here flatten it. That's mean flatten the layer, and once the layer is flattened, then I'm gonna add here the batch normalization. All right, add batch normalization. Thereafter I'm gonna add here the model dot add. It's like now I'm gonna add here the fully connected layers, and that we can add with the dense layers. Inside the dense layer, I'm gonna add here 2048 dense layers there. And this the activation function, I'm gonna use here this the ReLU activation function. And after this dense layer, once again I'm gonna add here this the batch normalization. All right, perfect. So after doing this, once again I'm gonna do this the same thing, but with the less number of fully connected layers. So 1024 layers only, and then the batch normalization. And then finally I'm gonna add here the final dense layer, so which will be used for the classification there. All right, so dense there, I'm gonna just add there one node there, and in the final one activation mode will be here the sigmoid, because this one is the final layer. So in this sigmoid, All right, so this sigmoid will be giving us the probability there. All right, 1 and 2, that's mean either male or a female there. And thereafter we are going to put here this the model layers. All right, so there the model layers 0, that's mean the first layer is not trainable equal to false. All right, perfect. Let's go ahead and run it. Now we are gonna make layer 0, that's mean the first layer of the model is non-trainable. All right, it says that this path is not defined. We need to see this if we have not run this. Let's go ahead and run it once again and see this. Okay, so it still says that some issue is there. All right, so it's not able to download it from there, seems like. Okay, so it's not able to download it there. So what we can do, we can directly pass there this the ImageNet path directly, so it will automatically download that for Inception version 3. All right, perfect. Now you see there it's directly downloading it, actually the Inception version 3 weight. It's actually the same weight which we had earlier there, but only the reason is that this weight is without any top, that's mean non-trainable. All right, so the top layers are not trainable because we don't want to fully train this Inception version 3. We just want to train only few layers of the Inception version 3 because it is already pre-trained model. All right, so you get here the model dot summary here. That's how you get the model summary here. All right, so this one is the model summary. Total number of parameters are here. Total 28 million parameters seems like. Trainable parameters are 6 million and almost 22 million parameters are non-trainable. The reason is that this is non-trainable because here we set it false and we are also not including the top layers for the training there. All right, perfect. Now let's go ahead and put our model in the training. So first of all, we need to compile our model. So the model dot compile here, model dot compile, and there I put here this the optimizer is equal to Adam optimizer, and then the loss function I'm gonna put here this the binary cross entropy. All right, thereafter I say here this matrix is equal to, I'm gonna use here this the accuracy matrix. All right, so it's going to use here a binary cross entropy loss function, and Adam optimizer will be used, and the metrics of the, that's mean how our deep learning model will be evaluated, that is based on the accuracy. All right, let's go ahead and train our model. So we are going to read it inside the history because we will be also plotting our the training journey that we can do, but I think we will be just doing it for one single epoch, so we don't need that. So the model dot fit here. Okay, model dot fit here, we have here the train data generator. All right, so there we have the train, sorry, it's the train generator. All right, that's the training data, and then I say here the steps per epoch. That's in how many steps are going to be the per epoch, that I'm gonna get it from this the length of the train generator file names. All right, length of there, this the train generator dot file names. All right, so it means if you see there how many images are there, with this you can get all these things there, and there is this length is there. All right, so this one is the total length there. So it says that the steps per epoch, I mean how many steps it is going to be trained per epoch, that's the total one there, and divided by here, I'm gonna do here the division, so divided by batch size. All right, so there I say the batch size, how many what is the batch size there? So the batch size is here 128, right? Perfect. And if you do here the division there, so I put here the double forward slash, because if I put here only 1, it will give the result in a decimal points, but here I do like this. So there, now it is giving you the integer there. So that's the steps per epoch. And thereafter here it is asking that, just a second, let me see here. I think I closed this here, right? So it should not be closed there. So thereafter it is saying that how many epochs are there. If you remember earlier, I told you that there would be only one epoch, and I think I had given there total 50 epochs there. But here we will be doing this only for one epoch, right? So later on you replace this one to this epoch, that's when the 50 epoch. Since this is online tutorial, so we'll be just doing it simply for one epoch only. Otherwise we can take it maximum 2 there, all right? Otherwise there would be a lot of the time will go into the training only. All right, so there is epoch 2, and thereafter we are gonna put here this the validation generator, right? In the it's actually the validation data equal to validation generator. All right, that's the validation data. And the similar thing we will be also putting here the steps per epoch for the validation as well. So we say here this the validation steps, validation steps is equal to length of validation generator dot file names divided by here the batch size. All right, perfect, superb. Let's go ahead and run it simply. So you once run it, you will see there the model training has started. It should not take more, more than 4-5 minutes. We have to see that how much time it is gonna take, and once this model is trained, then we will again start this video lecture. All right, so by training only 2 epoch, we have got almost the accuracy of the 90%, which is quite good. Okay, not a bad accuracy. So thereafter, once your model is trained, now it is time to test your model with the data. So we have here 2 options. One option is test on these phases, although we have already trained on these phases, and another option is to test on a real data. All right, so first of all, just for the purpose of the evaluation, I'm gonna test it here. All right, so for that I'm gonna write here just the test model. All right, thereafter here I have okay, like this. So in the test model we need image path. So I'm just gonna take here some default image path from here. Okay, I'm just gonna take it here, the copy this path from there. I say here this the img path equal to this. So the moreover whatever image is this, we are gonna just classify and see what is going to be the gender of this image. All right, so after getting the path of this image, our task is to load this into a numerical data, and that we can do from TensorFlow .keras .preprocessing import image, and thereafter okay, it is saying that here's the something is wrong. Let me see. Okay, this should be correct. This should be not wrong. So just to solve this purpose, if you remember here, we had actually imported this load image from here itself. So I'm just gonna copy and paste it here just for your reference. All right, so here this one is there. I'm just gonna remove that one. We don't need to re-import it again. I'm just putting here for your reference there. From the TensorFlow.keras pre-processing image, we are importing here a load image and image to array. So we are going to call here this load image, which I'm going to store in img. So there I say here load image, and there I need to put here the path of the image. So I say here this img path from where we are gonna load the image, and then the target size, if you remember, it was the target size 224 cross 224 there. And thereafter we also need to put here the third dimension as well. So the moreover I'm gonna put here something like this, size and then 3. All right, and then I say here the plt dot imso there. All right, so that's what we are getting here. If you see, this image is there. Now our task is to convert this image into a numerical data. So that we can do like this, img is equal to image. So image to array, right? So this one, img to array. So I have here this img. Now it is converted into an array. And now if you check the value of this img, it is in between 0 to 225. And now we need to convert this value in between 0 to 1. That we can do like this, img divided by 255. All right, so with this we will be getting this into a numerical value there. All right, so once it is done, then we need to reshape it. So img is equal to img dot reshape, and there I'm gonna reshape into size cross size and 3. So why this additional one needed? Because this one is actual the image size. So we are gonna say that there is the image and this the array of one image only. That's why we need this 3-dimension array into a 4-dimension. So we had to change this. So it's like, because this one is the size of image and this one says that the one array, that's mean the array of images there. All right, so that's what we have got here. Now if we check the shape of the image, now it is the 4-dimensional image, right? That's what we need here. Let's go ahead and do the model dot predict here, and in that we need here this img. So in this we have here a very small value. A small value means it is a female. If you remember, there we had some here, this one, the class, I think it was something else we need to see there. It was not the class, it was here. Okay, so there the 0 belongs to the female there and 1 belongs to the male there, right? This one 0 is the female. So a smaller a value, if this value is lower than 0.5, that's mean that is going to be a female, right? A strong recommendation to be female. If it is nearby 1 or greater than 0.5, then it will predict as a male that. All right, perfect. So just to get these, the male and the female only, instead of getting these, how we can do this? We can simply create here one function there. So that function I'm going to say here def get underscore classes, and in that I pass the data, which is img data. Then I get first the probability here. So the probability is model dot predict image. All right, so this one is the probability here, and thereafter I'm also gonna get here the prediction. So the prediction I'm gonna get it here, np dot max argument. That's mean it is going to get the index there, max arg, and then I put here the probability axis is equal to 1 here. All right, so I say here if pred 0 equal to 0, then it will return here this female and of course the probability, whatever the probability is there. So this is the 2-dimensional array there. So we need to get the value by doing this, and similarly it's going to return here male something like this. All right, so that's what it is going to do. And then simply you can say there here get classes, and in that I pass here this img. All right, so it says that this one is the female, and the probability is actually the quite strong here. There, if you notice this, the probability is actually the quite strong. So to better to get this probability, we can say that here like this 1 minus this, because this one for the female. So if you do like this, you will get here the correct probability. For the male, it will be as it is, because male will tend to 1, but for a female, it has to be 1 minus the probability of the male. All right, 1 minus the probability of the male, that's mean the probability of the female. So it says that the probability of the female is 99% for this picture, and definitely this is what it is. All right, so this one is predicting the probability on a given data, which we have already used for the validation, and that's not the correct way to do that. So for the another purpose, I'm just gonna get here male picture. All right, so I'm just gonna get here the male picture. So any male picture you can get from here. Let's say I'm gonna get it this one, and then I'm just gonna save this. I may get this the copy image. I don't know if that is gonna work, but let's say if this works, img path is equal to something like this. I don't know if it is gonna work. We need to see that. It does not work, seems like. Okay, so if we remove this one, will it work? I don't know. Well, so that's not gonna work here. Perhaps we need to get it. We need to get it here in our computer, and then we will upload it. All right, so save image, whatever the name of this image is, as it is. The download, I'm gonna just do it here inside there. That's the download there, and then I'm gonna upload this file here from this download. All right, just I'm gonna rename it male jpg. All right, perfect. So that's the male jpg is here. I'm gonna get the path of this file, and then I put it here. Superb. So there we have got it. Let's go ahead and rerun it once again and see what result we are gonna get it. So it says that this one is being predicted as the female. All right, this one is being predicted as the female, although this is not the female. The reason is that here, this one is saying that how much? It's saying that 0.92, and this is going towards the this is going towards the female. Sorry, this is going towards the male. So we have done here a little wrong here. All right, so that we need to make sure that we do it correctly. So instead of doing this, the pred there, whatever this the pred we have here, it has to be something like, let me just tell you here, something like this. If 0, 0, that's going to be the probability there. If this prob is less than or equal to 0.5, then we say this one. All right, that's mean the female. Otherwise it is going to be male. I think this one will work correctly. All right, just run it. Perfect. So it says that this picture is for male with this probability, and once again if you change it here for a female, we will be getting here the female there, right, with the correct probability. All right, so now it is for a female with this much of the probability. So this is how we can get the data from the internet and get it predicted. Now let's go ahead and see how we can do this, the live testing. Okay, real-time prediction using webcam. All right, so I'm going to use here the webcam, and to use this webcam there are codes. So there are codes which code I have already copied from the the internet. So that code seems a little complicated, so that's why I just copied this whole thing there. I'm just gonna show you that code here, this whole code. All right, so you can get it like this. If you just copy it here and paste it here, something like that, you might get this one. All right, so there in this, the face detection, you will get this whole code there. All right, so this one from the Google Colab. All right, perfect. So there we got the code from there, and I used that code as it is. If you want to know more about this code, you can simply search this on the Google. You will get here the so many things there. All right, video capture and other things. There are codes there on this Stack Overflow as well. All right, so they have explained it here. I think this code is there as well. All right, so these codes you can get, so I'm not gonna deeper inside this code because it will again take a lot of the time to explain this thing. You can simply copy and paste that code there, and thereafter I'm gonna just write here to capture, write this code to capture the picture there. If you open this one, so to capture the picture, this image is there. Okay, the take photo is there, and there this one is going to capture the picture there. So that's what I did here. This, I'm going to capture the photo here, and then I'm going to save it here. All right, perfect. So once I run this, it's going to start my camera, and then it will start capturing my photo. All right, let's go ahead and run this. So as soon as I run this, it's going to turn on my webcam. You may also need to allow your camera from here. So in notification, it says that allow, and I allowed the camera. Now it's gonna start this. This is beautiful. All right, so it has just started my camera here, and you can see here clearly to me. So once this is there, once you start seeing your picture, only you need to click on here, this, the capture. All right, so this capture, click on just capture here. All right, so there you got this, the picture is there. Now once you got this picture, then this picture is saved here actually. Right, this the photo.jpg, this picture is saved there. Now we need to actually detect the probability of this one. All right, so how we can do that? We can actually simply copy either this, the whole thing which we did earlier here, like these things. All right, otherwise I have also written a function, so just to make the things clear here. So this function is there. So the get prediction, the image path, this is the same thing here we are doing. We are actually loading here. So that is going to be the size here. That is also the size there. All right, so there we are loading the image as we did earlier. Then we are also displaying the image again. And thereafter this image is going to be converted into a numerical values. Then the value of image is going to be converted from 255 to 0 to 1, and then the reshaping in a 4-dimensional array, and then finally the prediction there. All right, so simply I get here this one, the copy of this path, and then I say here this the get prediction. All right, and just pass this information. All right, this says that this image, actually I'm sorry, this should be this one, like we did earlier, right? This one. All right, so here it says that image size is also not there. I'm sorry. This should be actually size only. This is the picture, and this says that this is the female. This is definitely not correct. This is definitely not correct. All right, and if we get it through our the previous one, which is here, if we replace it here, let's go ahead and replace it here. All right, img path is equal to like this. Thus the content photo is there. Okay, let's go ahead and see that here. Once again, this is the picture. So the reason could be that because we trained on a very much cropped picture, and that could be the reason there. So let's go ahead and do this. Okay, load it again. Definitely, now it is saying there it is the male there. So why it said there it is a female? I'm not sure why it said there it is female. There could be something is missing, might be. Okay, so now it is saying that here it's actually the male with the 60% the probability. All right, so the reason is that there is a lot of the background is coming. If you again zoom the camera there and you again get that picture there, so with a more clearer with the more clear face, then it will be correct there, right? Well, seems like it is giving, it was giving the data wrong, because this data, I used this data, but here it was the image. That's why it gave us the error there. I mean, a wrong prediction, because this data was not being passed here. It was taking the image, right, from the previous one. Now, if you run it again and you come here, run it again, now you will be getting the correctly here, although this is the old file. So what I'm going to do here, I'm going to adjust my camera again, and then I'll click one more photo. All right, so I have adjusted my camera. Let's go ahead and click one more photo once again. So for that, I need to run this code again. All right, so this is going to capture a more clearer pictures. So it's starting it. Now you see this one is capturing here like only my only my face here, right? Not much of background is coming here. It's only capturing the face there. And let's go ahead and just capture it here. Where is that, the capture button? That should be somewhere here. All right, this is here. All right. Well, so there we have got this picture. Once again, the old picture is overwritten. Let's go ahead and see. Now you see this one is the old picture. There is a lot of the background. Now this time we should not get those background once we run this, right? Now you see those background has gone. Now we have got here the more the clear pictures, and that is why the accuracy of being predicted as the male, this has increased to the 74 or 75% here. All right, perfect. So this is not 100% accurate model. The reason is that we had only trained it for only the 2 epoch, and the accuracy was only somewhere 90%. That's mean there is the 10% of the error chances are still there. All right. Perfect. So I'm sure you have learned a lot in this lecture. You have learned how to classify your image in a male and the female, how to load it through the data generation directory. I mean, how to convert these image data into the numerical values and all those things. Thank you so much. If you liked this video, please do not forget to subscribe this channel and like this video. Bye-bye. Have a nice day.